This is a question where they give us a function of three variables, namely the function f is a function of x, y, and z, so three independent variables, and the function is given by x times y times z to the power of 7. And the variables x, y, and z themselves depend on t, namely x is equal to t, y is equal to e to the t, and z is equal to t cubed. The question is asking for the derivative of f with respect to t, specifically when t equals 0. So notice that f in its definition is not a function of t, and they are asking for the derivative of f with respect to t. So we're going to have to use the chain rule, because the only way to get how f is changing with respect to t is to go through the variables x, y, and z, because those are the variables that are defined in terms of t. So we're going to need the chain rule here, specifically the chain rule for three variables, and so we'll just write it down now. The derivative of f with respect to t is equal to the derivative of f with respect to x times the derivative of x with respect to t. This essentially gives you how fast f is changing with respect to t because of the variable x, or via the variable x. However, f also depends on y, so we need to know how much the variable f, or the function f, is changing with respect to t because of the contribution through y, so that's this term. And then finally, because f also depends on z, we would like to know how much f is changing due to with respect to t, because of the fact that f depends on z and z depends on t. So these are the three contributions from x, from y, and from z. And so now we need to just calculate these partial derivatives that we see here. So the partial derivative of f with respect to x is, so we have this is the function f as far as x, y, and z are concerned. So this becomes 7 comes down, x, y, z to the power of 6, and then we multiply by the derivative of the inside with respect to x, and that is just yz, times, now we take the derivative of x with respect to t. The derivative of x with respect to t is just 1. So that's the first term, that's the first piece. The second piece is the derivative of f with respect to y. So here's f again. So the derivative of f with respect to y is 7 x, y, z. The 7 comes down, reduce the 7 to a 6, and now we take the derivative of the inside with respect to y, so this becomes x z, just going to put this in brackets here, times the derivative of y with respect to t. So the derivative of y with respect to t is just e to the t, plus the last term here is the derivative of f with respect to z. So let's take the derivative of f with respect to z again. That's 7 times x, y, z to the power of 6, times the derivative of the inside with respect to z, which is x, y. And then we multiply by the derivative of z with respect to t, which is 3t squared. Okay, so this is the essentially the rate of change of f with respect to t. However, they would like it specifically when t equals 0. So, of course, we could just plug in t equals 0 into all of this, but we'd still have some x's and y's and z's hanging around. So what we need to know is we need to know what are x, y, and z when t equals 0. So when t equals 0, x is 0. When t equals 0, y is equal to e to the 0, which is just 1. And at t equals 0, z is equal to 0 cubed, which is just 0. So this is 0 cubed, which is just 0. So now we know that when t equals 0, x is 0, y is 1, z is 0. And so we can sub in x is 0, y is 1, and z is 0 into our derivative here, as well as the fact that t equals 0, and then we can come to a number. So let's actually go ahead and do this. The derivative of f with respect to t at t equals 0 is equal to, okay, so wherever we see an x, let's put in a 0. So this would be 7 times 0 to the power of 6. So this becomes 7 times 0 times what is y, y is 1, times what is 0, or what is z, z is 0, to the power of 6, times y times z. So y is 1, times z is 0, we still have this 1 hanging out here, plus 7 times x is 0, y is 1, z is 0, to the power of 6, times x times z, so x is 0, z is 0, times e to the 0, because we've substituted 0 for t now. And then the third term is plus 7 times 0 times 1 times 0 to the power of 6, x times y, 0 times 1, times 3 to the 0 squared. Lots of zeros in here, and I think what we'll find out is this whole thing is 0. Of course, this is 7 times 0 to the power of 6. 0 to the power of 6 is 0, so that wipes out this whole thing. 0 times 1 times 0 times 1, that's all 0. The second term is 7 times, again, 0 to the power of 6 is 0, times 0 times 0 times 1, that's 0 again as well. 7 times 0 times 1 times 0, that's 0. 0 to the power of 6 is 0. 7 times 0 times 0 times 1 times 3 to the 0 squared, that's all 0 as well. And at the end of the day, we find out that the rate of change of f with respect to t when t equals 0 is just 0.